Gases and liquids are considered fluids. Hydraulic devices use liquids, usually water, flowing under pressure. Liquids have no definite shape. They take the shape of the container. They have definite volume and are not compressible. Gas systems are called pneumatic systems that are used under pressure. Gases have no definite shape, no definite volume, and are compressible. We can measure pressure two different ways. The first way is called the gauge pressure. Gauge pressure is pressure in a system, not including the atmospheric pressure. Anything above the atmospheric pressure is a positive gauge number. Anything below the atmospheric pressure will have a negative gauge number. Absolute pressure is also known as total pressure. Absolute pressure equals the gauge pressure plus the atmospheric pressure. This is also known as barometric pressure. You learned in chemistry what atmospheric pressure is. Atmospheric pressure at sea level or standard pressure is 14.7 pounds per square inch or 1 atm. So if we are in the imperial system, we will use pounds per inch square or psi. If we are in the metric system, the SI unit is pascals or pa. This is also a review from chemistry, gas law. The three gas laws you need to be familiar with is Boyle's law. When everything else is held constant, it tells you the pressure of 1 times the volume of 1 is equal to the pressure of 2 and the volume of 2. This tells you as pressure increases, volume decreases, vice versa, so they're inversely related. Charles' law, when everything else is held constant, is volume over temperature is equal to volume 2 over temperature 2. Volume and temperature are directly related, so that means as volume increases, so does temperature. If volume decreases, temperature will decrease. The third gas law you need to be familiar with is called the Gay-Lussac. When everything else is held constant, pressure over temperature is equal to pressure 2 over temperature 2. Unlike the units in chemistry, we will be using the imperial system. The units for pressure in imperial is pounds per inch squared or psi, as we mentioned earlier. Therefore, the volume has to be inch square. Since we are in the imperial system, we are using Fahrenheit system. When we calculate for gas laws, we must always use the absolute scale. So the temperature must be converted into Rankine, which is written as degree with a R. A Rankine is equal to the degrees Fahrenheit plus 460. All temperatures in gas law must be in absolute scale. So what is pressure? Pressure is force per area. So P is equal to F over A. Force units are Newton. Area units are meter square, which is equal to a Pascal in SI units. If you calculate this in the imperial system, force will be in pound and area will be in inch square, so you get PSI. So let's look at this example. On the right, we have a high heel shoe and I have sneakers. The force would be my weight when I wear my high heel shoe or my sneakers. My force would stay constant because my weight is the same. However, the area is different. When I wear my high heel shoes, the area is much smaller. Since pressure and area are inversely related, the area is small, my force is constant, so my pressure increases. While if I wear my sneakers, the area is much larger, so my pressure is going to be smaller with my same weight. That is why when I wear high heel shoes, my feet hurt versus when I wear sneakers. And when we are talking about the area, we are talking about the bottom part of the shoe here. So this is why flat shoes like sneakers, boots are a lot more comfortable on the feet. Pause the video and try this problem on your own and then check your answer. So we have a pneumatic system is producing 100 pounds per inch squared of gauge pressure. A cylinder is needed to press an adhesive label onto a product. It is determined that 5 pounds of force is optimal to complete the task. So draw and label the picture. So we have a cylinder and the cylinder will exert 100 pounds per square inch, and it is pressed on an adhesive label that is down here. This force that is going to be exerted is 5 pounds. The next part, what is the area of the pneumatic cylinder? Pressure is equal to force per area. We know that pressure is given as 100 pounds per inch squared. This is equal to 5 pounds. When we're solving for the area, we rearrange, so area becomes 0.05 inch squared. Pause the video, try this problem on your own, and then check your answer. We have a hydraulic lift system that uses two 3-inch diameter cylinder. Workers must determine how much system is capable of lifting before deciding how much weight can be lifted safely. The system runs at 2,000 pounds per square inch. The first question it asks is, what is the area of each piston? Since it's a cylinder, the area is going to be the cross-sectional area, which looks like a circle, and the diameter here says it is 3 inches given right here. So area is equal to pi r squared. Since they gave us the diameter is equal to 2 times r. So that means r is going to equal to diameter divided by 2. So if I plug that in, that's going to be pi times d over 2 squared. So this is the same thing as pi over 4 times the diameter squared. So this equals to pi over 4 times 3 squared, which equals 7 inch squared. Part B. How much is the system capable of lifting? So we are looking for the force. So pressure is equal to force per area. The pressure was given as 2,000 above pounds per inch squared. This is equal to force. The area we calculated was 7 inch squared. Solving for force, you should get 30,000 pounds. Pause the video, try this problem on your own, and then check your answer. The gauge pressure of a pneumatic cylinder reads 20 pounds per inch squared when the volume is 30 inch cubed. The cylinder is compressed until the gauge reads 60 pounds per inch squared. What is the absolute pressure before and after the cylinder gas is compressed? Absolute pressure is the total pressure, so P total is going to equal to the P gauge plus P of the atmospheric. P of the atmospheric at sea level is 14.7 pounds per inch squared. So the gauge pressure before it is compressed is given as 20 pounds per square inch. That's going to be 20 pounds per square inch. The atmospheric pressure is a constant, which is 14.7 pounds per inch square. You add that, this is going to be 34.7 pounds per inch squared. Next, they want the after. We're going to use the same formula, but the gauge reads 60 pounds after. So that tells you P total is still gauge plus atmospheric, but the gauge is now 60 pounds per inch squared. Atmospheric pressure is still a constant, 14.7 pounds per inch squared. This equals to 74.7 pounds per inch squared. Pause the video, try this problem on your own, and then check your answer. What are the absolute temperature readings initially and after the temperature has been raised? If the air temperature in a 28-inch cube container with free sliding piston is initially measured at 45 degrees Fahrenheit, the raised temperature is 200 degrees Fahrenheit. Whenever I do gas laws, temperature must be in absolute scale. Since we are in Fahrenheit, we are going to be using Rankine. Rankine formula tells you degree R is equal to degree F, which is Fahrenheit, plus my conversion factor, which is 460. So initially, the temperature was at 45 degrees Fahrenheit, plus the conversion factor. So my new temperature will be 505 degrees Rankine. We want the temperature after the new temperature was raised to 200. So the Fahrenheit degrees is 200 degrees Fahrenheit plus 460, which equals to 660 degrees Rankine. Pause the video, try this problem on your own, and then check your answer. An expandable container is filled with 28-inch cube of air and is sitting on an ice water that is 32 degrees Fahrenheit. The container is removed from the icy water and is heated to 200 degrees Fahrenheit. So again, if you're struggling, identify the variables. So we have a volume because inch cube is volume. So volume 1 is 28-inch cube. It is sitting in ice water, so that's a temperature 1. And this is 32 degrees Fahrenheit. The container is removed from the icy water and heated. So we have a temperature 2, which is 200 Fahrenheit. And we're looking for V2. So the only gas law with 2 V's and 2 T is Charles' law. So that's going to be V1 over T1 equals to V2 over T2. Since we are using gas laws and Fahrenheit, the first thing I need to do is I need to convert all the temperatures into Rankine. We know the general formula is equal to degrees Fahrenheit plus my conversion factor, which is 460. So my temperature 1, I'm going to add 460. My temperature 2, I'm going to add 460. So my temperature 1 becomes 492 Rankine. And my temperature 2 becomes 660 degrees Rankine. Now I'm going to plug in. My V1 is 28-inch cube. My T1 we solved it as 492 degrees Rankine. We're looking for V2 and my T2 is 660 degrees Rankine. So you could cross multiply this if you want, or you could divide 28 divided by 492, then multiply by 660. So my volume 2 becomes 38 units of inch cubed. Pause the video, try this problem on your own, and then check your answer. So 300-inch cube sealed air tank is sitting outside. In the morning, the temperature inside the tank is 62 degrees Fahrenheit, and the gauge reads 120 pounds per inch squared. By afternoon, the temperature inside the tank is expected to close to 90 degrees Fahrenheit. What is the absolute pressure at this point? Again, if you're struggling, identify the variables. If I identified this is my volume because it is inch cube. So my volume is going to be 300 inch cube. My volume here is going to be a constant because the tank is sealed and the tank's not going to expand. It's a metal tank. So in the morning, the temperature inside the tank, temperature 1 is going to be 62 degrees Fahrenheit. The gauge pressure is equal to 120 pounds per inch squared. By the afternoon, the temperature inside the tank is close to 90. So my T2 is equal to 90 degrees Fahrenheit. And we're looking for P2, which is an absolute pressure. The gauge pressure was given. So first thing I need to do is convert my gauge pressure to my absolute pressure. So my P total 1 is going to be P of the gauge plus P of the atmospheric, which is equal to 120 pounds per inch squared plus 14.7 pound per inch squared. 134.7 pounds per inch squared. The temperatures also need to be converted because they must be absolute. So we know that Rankine is equal to degrees Fahrenheit plus 460. So for T1, this is going to be added 460. This is equal to 522 Rankine. My T2 is also in Fahrenheit, so I have to add 460, and so this is going to be 550 Rankine. And now I'm going to plug in. I have 2 P's and 2 T's, so I know this is going to be the Gay-Lussac's formula, which tells me is P1 over T1 equals to P2 over T2. My P1, we're not using 120 because we want absolute. We're going to use 134.7 pounds per inch squared. My T1 we calculated in Rankines as 522 degrees R. Pressure 2 is what we're looking for. My T2 we calculated in Rankines to be 550 degrees R. So we're going to multiply and divide. So 134.7 divided by 522 times 550, and our pressure becomes 140 pounds per inch squared. Pause the video, try this problem on your own, and then check your answer. So a cylinder is filled with 40-inch cube of air at pressure of 60 psi. The cylinder is compressed to 10-inch cube. What is the resulting absolute pressure? We have a volume, so my V1 is going to equal to 40-inch cube. If you get stuck, look at the unit. The units will help you. 60, this is in psi, so we know this is pressure 1, 60 psi. The cylinder is compressed to 10-inch cubes. That's a second volume. What is the resulting absolute pressure? That is P2. We're going to look for that. Since we are looking for the absolute pressure, my initial pressure must be converted into absolute. P total is equal to P gauge plus P atmosphere. P gauge is given as 60 psi. P atmosphere is 14.7 psi. So my total pressure is 74.7 psi. Two volumes, two pressures. This is Boyle's law. So P1 V1 equals to P2 V2. P1 is 74.7 psi. Volume 1 is going to be 40-inch cube. My pressure 2 is P2. My volume 2 is 10-inch cube. Multiplying the left, dividing by 10, your P2 should be approximately 300 psi or pounds per inch squared. Pascal's law or Pascal's principle tells you that pressure applied at one point of a liquid is transmitted equally in all directions. That tells us that pressure of 1 over the area of 1 is a constant. This is going to equal to pressure of 2 over the area of 2. Most of you have taken your car into the shop. They put your car on this lift, and the way they lift it is they apply a force by pushing a button in one area. That force exerts a pressure. Area is the cross-sectional area, which is really tiny. So the force in that area is also small. Therefore, the pressure is small. On the opposite side, the force is great because the area, which is this cross-sectional area, is much bigger. And since they're related proportionally, P over A is equal to P2 over A2, you are able to, by pushing a button, exerting a small force, able to lift a larger object because the pressure is transmitted equally in all directions by increasing cross-sectional area. So the work input must always equal to work output. You will not see calculations for Pascal's law on the test, but you should understand what the concept is. Flow rate. Flow rate is the volume of fluid that moves through a system in a given period of time. So flow rate is volume. Flow velocity is the distance the fluid travels through a system in a given period of time. So we can measure a flow rate, which is symbol Q, is equal to V times A. The flow rate, which is Q is equal to V times A, is the flow velocity times the cross-sectional area. This area here is the cross-sectional area. Is if I have a pipe that is a cylinder, it is this. If I cut it in half, inside the circle looks like that is my cross-sectional area. The flow rate Q, units can be gallons per minute. It could be inch cube per minute. If you are in the metric system, it could be in liters per minute or liters per second. V is the flow velocity, which is the distance it travels. It is feet per second or inch per minute. A is the cross-sectional area in inch squared. So in a system, the flow rate is constant. If or the cross-sectional area is large, my flow velocity will be smaller. Flow velocity, since it is the distance per time, this is similar to speed, how fast it is traveling. If the cross-sectional area is very large, my velocity is going to be smaller. My cross-sectional area is small, my velocity is going to be much faster for the fluid. fluid. If you have a garden hose and you turn on the water, water will come out at a rate, this flow rate Q. If I close part of the cross-sectional area with my finger, since the area is smaller, the velocity of the water coming out of the garden hose is much faster. If I close even more, it comes out even faster. If I open it back up, the water flow is much lower. So flow rate is a constant in a system. You could change its flow velocity by changing the cross-sectional area. They are inversely related. Pause the video and try this problem on your own and then check your answer. A flow meter is attached in a hydraulic line that measures 12 gallons per minute. The line has an inside diameter of 1.5 inch. Draw and label the diagram. So we have a line, so that means pipe here, and we have a flow meter which is connected to it like this. It is traveling, its flow rate is going to be 12 gallons per minute, and the inside diameter is about 1.5 inch. The question is, what is the flow rate? So we're looking for Q, and the Q is given 12 gallons per minute, and we want to convert this into inch cube. So we do not want to write it like this. We want to write the numerator unit on top and the denominator unit on bottom. By looking at this, we only have to convert the top unit because the bottom unit has to be in minutes. So how do I convert this? Diagonal units have to be the same. This is gallon. I'm going to go to inch cube, and all of these conversion factors are given in your equation sheet. So 1 gallon is equivalent to 231 inch cube. So in front of inch cube, we're going to add 231. In front of gallons, we're going to add 1. Gallons will cancel out, and we have the units that we want. Inch cube on top, minutes on bottom. So if I multiply this is going to be 12 times 231 divided by 1, which gives us 2,772 inch cube over minute. So on C, it asks for what is the area of the diameter of the line. We know the diameter is 1.5 inch. D is equal to 1.5 inch, but we're looking for the cross-sectional area. That means that's going to be a circle because it's a kind of like a pipe or a line which is circular. Area is going to be pi r squared. So if the diameter is given, this is equal to 2 times the radius. That means r is going to be 1.5 inch divided by 2. So if I plug this in, this is going to be pi times 1.5 divided by 2 square. This is equal to 1.8 inch squared. On part D, what is the velocity or the flow velocity where the fluid passes the meter? We know the equation is Q is equal to cross-sectional area times the flow velocity. In a given system, the Q stays constant. It will adjust depending on the area, but the Q or the flow rate will remain the same. So the Q, we calculated that above as 2,772 inch cube per minute. Calculate the cross area right above in part C, which is 1.8 inch square, and we're looking for the velocity. By plugging in, this becomes approximately 1,566 inch per minute. The biggest issue in this section is you need to make sure the units are alike. Remember, there's two types of pressure. There is gauge pressure and atmospheric pressure. Atmospheric pressure is the total pressure. So you always add gauge to 14.7, which is the standard pressure. We are using imperial or the English system. We will not be using 1 atm. Pressure is force per area. Greater the area, the smaller the pressure. The smaller the area, the greater the pressure if force is held constant. Note all the gas laws. Boyle's law is PV equals PV. Charles' law is volume over temperature. Gay-Lussac's is pressure over temperature. Read the question carefully. If they're asking for absolute pressure for gas laws, you must convert the initial pressure into absolute or the total pressure. Temperature must always be converted to absolute scale, or degree Rankine is equal to degree Fahrenheit plus 460. You cannot use Fahrenheit because Fahrenheit has negative values, so you're going to have negative volumes. Flow rate tells you that for a system, the flow rate is constant. it will remain constant by either increasing the cross-sectional area and decreasing the flow velocity, or the velocity will be greater and the cross-sectional area will be smaller.